Hi, in this video we're going to look at the relational model, and the topics we're going to look at are the relational model terminology, properties of relations, relational keys, integrity constraints and views. So when we're looking at a relation or the logical structure concerned with a relational model, basically it's a two-dimensional table. All relations are a two-dimensional table made up of rows and columns. The table or the relation has a name like course or student or whatever, and then the columns are the attributes of the relation, and the rows then are the actual records. So a relation is a table with columns and rows. It only applies to the logical structure, not the physical structure. The attribute is a named column of a relation, and domain is a set of allowable value of one or more attributes. So for example, if you have an attribute course code, well then the domain would be the prefix and numbers that you define, such as like for when WIT, when it's in existence, its course code started with WD and was followed by 3 digits. Tuple is the row of a table. Degree is the number of attributes. Cardinality is the number of tuples or rows. And a relational database then is a collection of normalized relations with distinct relation names. So we're going to look at an example now. So here we have two relations, branch and staff. So branch has 4 attributes, so the degree of branch is 4, and the attributes are branch number, street, city and postcode. The number of tuples or rows or records that the relation has are 5, so the cardinality of branch is 5. In staff then, we have the degree is 8, staff number, first name, last name, position, sex, gender, salary and branch number. And the number of records or tuples is 6, so the cardinality of that relation is 6. So for, would say the domain of branch number in the branch table would be probably B followed by 3 digits, that type of thing. Okay, obviously for salary then there might be a range of values between 5,000 and 50,000 or something like that. Okay, examples of attributes, so names. So see there, branch is a set of, the domain name is branch numbers. It's a set of all possible branch numbers. Character size 4, range B001 to B999. For street, city and postcode, just characters. For the gender, we have there character size 1, value male or female, which may be even outdated at this stage. Date of birth then, ranging from the 1st of January 1920, and the format then, and again that date would be out of date now. So you would go, your date of birth would go from, we'll say 65 years from the current date or whatever. And then salary then, monetary 7 digits, range 6,000 up to 40,000. Okay. Just terms then, like we're going to be using terms of relation, tuple, attribute. Alternatives then, an alternative to relation is table, tuple would be row, and attribute column. And then older alternatives then would be correspondence for a table or relation would be a file, then a record for row, and field for an attribute or column. Okay, we're going to be looking at the properties of a relation now. So think of your relation as a two-dimensional table. The relation name is distinct from all other relation names, so basically each relation in your database must have a unique name. Each cell of a relation contains exactly one value, so you can't store multiple values for an attribute value. So you can only have one name, you can only have one address, you can only have one date of birth, that type of thing. Each attribute has a distinct name. Okay, so the attributes within your relation are unique as well, and the values of an attribute are all from the same domain. So if you come back to our example here, you will notice that all the city values down this column here, see they're all city values: London, Aberdeen, Glasgow, Bristol, London. You don't put in 22 Deer Street for city. Likewise for salary, it's all numeric values. That's what we mean by domain, and they all come from the same domain. Each tuple is distinct. There are no duplicate tuples, and that is implemented via the primary key, which we will see shortly. The order of the attributes is insignificant, and likewise the order of the records is insignificant. The relational keys then. Keys are a very important part of a relational database model. They're used to establish and identify relationships between tables and also to uniquely identify each record within a table. So a key can be a single attribute or a combination of attributes in order so that the combination would be unique. So candidate keys are defined as the minimal set of fields which can uniquely identify each record in a table. There can be more than one candidate key in any relation. Okay, well, you look at your possibilities. Then when you have your candidate keys, you compare them and then you pick your primary key. So usually the primary key is the one with the least number of attributes in it. So single attributes would be more preferable, and the attribute values that are least likely to change. Candidate key selected to identify tuples uniquely within a relation is a primary key. The alternate keys then are candidate keys that are not selected as the primary key. And a new key value then we have as a foreign key, and that's going to be the link between our two or more relations. So how we link relations together. So a foreign key is an attribute or set of attributes within one relation that matches the primary key value of another relation. So we will be looking at this now in more detail going forward. So in this example here, as you can see there, we have cardinality and degree marked out. Our primary key of branch is branch number, B0, and all your branch numbers then are unique. In staff, the primary key is staff number. Again, all your staff numbers are unique. And you'll see the branch number in staff and in the staff relation is a foreign key because the branch number matches the primary key value from the related table. So you can see that John White works in branch B005, which is 22 Deer Road, London. John Beach and David Ford both work, and who else? Susan Brand all work in B003, which is 163 Main Street, Glasgow. Julie Lee also works in branch B005, which is 22 Deer Road, London. And Mary Howe then works in branch B007, which is 16 Argyle Street, Aberdeen. Okay, so by joining the tables together then for queries, you can get the full information that you require, i.e. the address of the branch that a particular staff member works on. But we'll see that as we move on. Concerned then with having keys and implementation of the relational model are integrity constraints. And some of them, in a relational model, once you denote an attribute or set of attributes as being a primary key, and likewise when you denote attributes as being foreign keys, they bring with it some rules that are implemented automatically by the database system, and we'll see those. So the first integrity constraint is null, and when you leave a value blank when you're inserting a value or updating a value for an attribute value, and if you leave it blank, it means it's null, and the database assumes the value null. Null means that the value is unknown or unavailable at the moment. So here it says it represents a value for an attribute that is currently unknown or not applicable for this tuple. It deals with incomplete or exceptional data and represents the absence of a value. And it's not the same as zero, because zero can be zero in an exam, a zero in a bank situation might be a zero, you have zero money in bank balance, and spaces. So it's not the same as zero or spaces, which are values. Okay, so null means incomplete or not, it's unavailable at the moment. Entity integrity then and referential integrity. Entity integrity is concerned with the primary key, and automatically, as I said, when you implement an attribute as being the primary key of a relation, it means that the value must be unique and not null. So even if you have a composite key, say you have a composite key of two attributes, both of those attribute values must have a non-null value, okay, and the combination then must be unique. So entity integrity is implemented once you have a primary key, so your keys are going to be unique and not null. Referential integrity then is when you specify an attribute as being a foreign key, then the referential integrity rule states that either the foreign key value must match the primary key value of some record in the home table, or where the matching table, or the foreign key value must be null. Now it can be null if it's optional, but if you put it in as required, well then the foreign key cannot be null. But in theory, your foreign key value must match the primary key value of the primary key value of a record in the related table, or else it can be null. And we'll see examples of that in a minute. So they're just all primary for entity integrity. All primary key entries are unique, and no part of a primary key may be null. And for referential integrity, then the requirement is a foreign key may have either a null entry as long as it is not part of the table's primary key, or an entry that matches the primary key value in a table to which it is related. Every non-null foreign key value must reference an existing primary key value. So we take this example here. We have two tables. So in the first table there, we'll take table 2. We have department number, we'll say, and department location. And we have 3 departments, so the cardinality is 3, and we have 2 attributes of this relation, so the degree is 2. So we have 3, as I said, 3 tuples. 11 is Mumbai, 24 is Delhi, and then 13 is Noida. Then we have a related table, table 1, and in it it's for its employees. So we have employee number, their name, their age, and what department they work in. So the degree is 4, and the cardinality actually is 4. So employee number 1 is Jack. He's age 20 and he works in Mumbai. And how I know that is because he works in department number 11. Then employee 2 is Harry. He's 40, works in department number 24, which is Delhi. Then we have number 3, John. He's age 27 and he works in department number 18. Now that record would not be implemented in a database system, or wouldn't be acceptable. So basically you'd get an error because 18, it says department number 18. We don't have a department number 18 in the related table. So this is not allowed, as department number 18 is not defined as a primary key of table 2, and in table 1 department number is a foreign key. So that record, you'd have to change the value essentially of department number. And then lastly we have employee number 4, Devil, who's 38, and they work in Noida, department number 13. More general constraints then you can implement yourself, or the database system would implement them for you. So for example, in a property for rent table, the type must be house, flat or apartment. Likewise with course codes, first 2 characters must be a certain 2 values, and then you have 3 digits, that type of thing. And lastly then we're going to look at views. So when we get on to doing looking at our SQL and doing our select statements, we will find we'll be doing a large number of or larger select statements eventually that will involve 2, 3 more tables being involved in a select statement. So often what happens there, instead of the users having to write those statements every time they want to perform that particular select statement, they create what's called a view and save it, and then they can execute the view whenever they need it. A view basically is a subset of your tables, and you basically specify what data you want from your database, and you specify that for your view. They don't exist physically, they're just dynamic tables. Views are also handy as well in a multi-user database system, where in different branches that will say, if I'm working in Waterford, I'll only be allowed access to data from Waterford. So I won't have access to the base tables. I'll only have access to views, and views would be defined by maybe the data administrator or someone in management, and then I would only have access as an employee to those particular views. So views are very handy from a security point of view, but also from just getting subsets of the data, because tables can be very large and you're only interested in certain percentage of a certain proportion of all those attributes. So you're trying to target the views at only the views to end users and what they are what they're interested in. Okay, so a base relation is a named relation corresponding to an entity in a conceptual schema whose tuples are physically stored in a database. So again, a course relation, a student relation, that type of thing. A view then is a dynamic result of one or more relational operations operating on base relations to produce another relation. So it's like the output of an SQL statement. So maybe it would be select a first name, last name, street, town, county, course, code, a year from student where county is equal to Waterford. So they would give me all the Waterford students and what their, the names of all the students, their addresses, what course they're doing, what year they're in, but that would only be for students from Waterford, that type of thing. So a view is a virtual relation that does not actually exist in the database but is produced upon request. The contents of a view are defined as a query on one or more base relations, and the views are dynamic, meaning that changes made to the base relations are reflected then in the view. A view name may be used in exactly the same way as a table name in a select statement. Once stored, the view can be used again and again. So it's rather than rewriting the same query over and over, you can save it as a view. So if you're performing the same select statement over and over again, maybe on a daily basis or an hourly basis or even on a weekly basis, so rather than having to write that query each time, you create it once as a view and then you just select the view. One of the most important uses of views in a large multi-user system where they make it easy to use to control access to data for different types of users. So again, giving access to people only for the branches or the areas that they should have access to, essentially, or to fees that they should only have access to. Not everybody should see in an organisation what your salary scale is, that type of thing. So as a very simple example then, so we have an employee table here. We have PPS, first name, last name, phone, their job title, their pay rate, and the ID, their manager ID. So who's their manager. Obviously you can't let everybody in the company look at all this information. Only a very few trusted people would have select, update, insert and delete privileges to that entire employee base table. Everyone else would only have exactly the access that they require. So a simple example of a view, create view phone view as select first name, last name and phone from employee, and we're granting select on the phone view to the public. So if you're in an organisation and you're looking for Joe Blogs and you're looking up, you want to contact him, well then you'll have access to the phone view. But when you select, say I said select asterisk from phone view, and I know that's SQL you mightn't have seen before, but select asterisk from phone view would basically return me everything from the phone view table, and that would be the first name, the last name and the phone number for every employee. Okay, so I'm not getting the pay rate, I'm not getting who their manager is, I'm not getting their PPS number, I'm just getting their first name, their last name and their phone number, and that's given out to everybody. Here now is another example of a view. Create view job view as select the PPS, first name, last name, job title, manager ID from employee. So now PPS are unique for every employee, and you wouldn't want, not everybody should see your PPS number. So grant select and update on job view to managers. So only managers can see this information and they're allowed to read it and to change it. Maybe change their pay, they change their job title. Another one, so to payroll then, you're going to allow payroll to get access to employees' PPS, their first name, their last name and their pay rate. And again, you're allowing payroll to read this information and change it. And then we have putting in a where clause. So we're selecting the PPS, first name, last name, pay rate from employee for only people who work in sales, where their job title is sales, and we're giving that to managers. So you see, they get the idea there. So the purpose of views, they provide a powerful and flexible security mechanism by hiding parts of the database from certain users. It permits users to access data in a customized way, so the same data can be seen in different ways by different users, and it can simplify complex operations on base relations. So rather than writing a query that involves 2 or more tables, you create the view once and use it as required then. All updates to a base relation are immediately reflected in all views, and if a view is updated, well then the underlying base table is also updated. Okay, thank you.